Gather around, students. Today's topic is about gravity. Gravity and those aspects of it that they never mention. All right? As usual, here's a drawing about it. This little drawing is what you have saw countless times before. This blue mesh here is time-space, space-time, all right? And this is a mess in it. This mess is massive, duh. It has gravity. It bends the space-time around it. What we see as we approach the mass is that normal space, as we get closer and closer, is more bent and also more dilute. And in some explanations, this causes what we see as gravitational force, because my mass, okay, with which I approach is pushed from the denser space-time area towards the more dilute one, close to the mass, all right? This is what you have knew already. What they never show is, okay, but let's not forget this mass is not a point mass. It has contents, it has material in it. How does it look inside? Wow, look at that. You see? This mesh doesn't go anywhere. It gets more dense where there's material. Why? Because, and that's the important part, the mass it has to be held in space and time. To hold a mass in space-time, you need an amount of space-time, okay? This mesh has to hold the mass, all right? Duh, why is that so important? Let's compare, like, a little bit of area in here, okay? This is a two-dimensional thing, but this area here is supposed to be the same amount of space-time as we follow the mesh. It has to equal to this. Now what I want to say here is that this little area here has the same capacity to hold mass than this one. But this one is not occupied. This has capacity, a larger free capacity to hold mass. And this has here a smaller one because it's already occupied, okay? Its capacity to hold mass is being used. Okay, these areas here, they are not only flexible, they flex in order to optimize holding the mass that is within them. Okay, it's just a bit of food for thought, and with that, that's all I wanted for today's lecture.